some chemistry, and we're going to be looking at what makes something a mixture. Now, obviously, in that picture, I've got a nice mouth-watering picture of some pick and mix, and it's a mixture because there's lots of different types of sweets. And actually, mixtures in chemistry are kind of similar to that, but you will see as we go through today. So, you will need your exercise book or some paper, a pencil or pen, and actually I'd like us to have a go at doing an experiment. Now, if you don't have these things, if you don't have water, oil, spoon and washing up liquid, then you can do the experiment with me. You can watch me do the experiment. But if you'd like to have a go at the experiment with me, then go and collect all those things now. You just need a little bit of oil, you don't need lots. So pause the video, get your title written in your book, and collect all the equipment you will need today. Off you go. Okay, welcome back. Right, let's get started. So we're going to do a little bit of a recap on what particle diagrams are. Now, we know the three states of matter from before. I know we've done it in school before. We've done solids, liquids and gases. Now we're just going to do some particle pictures, diagrams to show what that looks like. So a solid. Our particles in a solid, okay, here's our particles. In a solid, all of our particles are arranged in rows, they are rigid, and they are touching, okay? So they don't move around, they are solid, they are in rows, touching, and are rigid, they don't move. In a liquid, they are still touching, but they are arranged randomly. And they're not arranged in rows. Okay, and they can slide past each other. So they are still touching, but can move around and they can slide past each other. They are not rigid. In a gas, they are not touching and they move quickly, and we use these little kind of symbols to show that they are moving. So gas, they are not touching and they move quickly. So arranged in rows for solid, rigid, do not move. Okay, in a liquid, arranged randomly. Touching, and they can slide past each other. Okay, and in gas, they are not touching, and move quickly. Okay, so that's our basic states of matter. Solids arranged in rows and rigid, they don't move, or if they do move, they vibrate on the spot. They don't really move around, they don't flow. In liquid, they are arranged randomly. They are touching and they slide past each other. In a gas, they are not touching and they move around quickly. Okay, so those are our particle diagrams, and we need to know kind of these particle diagrams for today. Okay, so you're going to be drawing these kind of types of diagrams as we go. If you'd like to, it might be a good idea now to pause and copy my diagrams now. Okay, another bit of recap. Pure substances contain only one type of particle. True or false? Pure substances contain only one type of particle. True or false? You don't need to write this down. Have a think. The answer is true. Pure substances only have one type of particle. Okay, there's not different colours, different types. It is just one type of particle. Is tap water pure or impure? Okay, we've got some options here. Pure because it only contains water particles. Pure because it contains water particles and salt particles. Impure because it only contains water particles. Impure because it contains water particles and salt particles. Now have a think to yourself. Kind of, you can get rid of some that you might think, oh, it can't be that because pure can't contain two types of particles maybe. Okay, answers coming up now. It is impure because because it contains water particles and salt particles. There are salt particles in our water, which we kind of need for ourselves. It doesn't make it salty water. It's not salty water, but we need the salt in our tap water. It is safe though, so don't worry. Okay, which diagram shows a pure gas? Now we've got two gas particle diagrams, but which one is pure and which one's impure? This one's pure, this one's impure. This one is pure. There we go. This one's pure because it only has one type of particle. This one is impure because there are two types of particles, and we can see that because one of them is coloured in. So we've got two different colours. It's just a diagram that shows us that that particle is different to the black particle is different to the empty particles. Okay, it's been coloured in, so we know they are different. So pure substances and mixtures. Here are some examples. We've got salty water, air, and steel. Now, how do we know that they are mixtures? Well, if we think about salty water, have a think. What two particles are in salty water? Okay, we've got salt and water. So we know that salty water has got water particles and it's got salt particles. So it's a mixture. It's not a pure substance. In air, have a think. You might know what gases are in air. We've actually got oxygen, nitrogen, and carbon dioxide particles in air. So again, it's a mixture. There is not just there isn't an air particle. Air is made up of oxygen, carbon dioxide, and nitrogen. Now, steel, a bit trickier, you might think, with this one. Steel is made up of two types of metal. It's made up of carbon and iron. So again, it is a mixture. It is not a pure substance. Now, how would we represent that in the particle diagram? Let's have a look. So salty water, again, if we think back to the ones that we did earlier, it's a liquid. So they're arranged randomly, they're touching, but we've got the two different types of particles. Now, the black particles might represent the salt. Okay, so we've got, if we had more salt in our water, we might have more salty particles to show kind of how salty the water is. But this one shows us that there are two types of particles in our water. In our air, we've got our different colour particles to represent that there is a mixture in here. And then steel, we've got our carbon and we've got our iron particles to show that it is a mixture. So all of these we represent with our particle diagrams with different colours to show that they are mixtures. They are impure substances. They are mixtures. Now, what do the particles in squash look like? So squash contains sugar particles and water particles, because actually when we make a cup of squash, we know that we put our squash in, then we add our water. So we know we are making a mixture. Now think to yourself, what state of matter is squash? How are the particles arranged? How many different types of particle are there? Now I'm going to show you an example of this one, and then for the rest of the lesson you're going to be doing your own particle diagrams as we go, and there's pause symbols to show you where you need to be drawing. But I'm going to show you how to do this one. So this is the one for squash. Okay, and if you want to, you can have a go and maybe see if you can beat me to it. So squash, let me get my visualizer in the right place. Oops. Okay, so squash. Now think to ourselves, squash is it a solid, liquid or a gas? Well, really, it's a liquid, isn't it? We know that. So we know that it's going to be randomly arranged. They're going to be touching and they can slide past each other. So we know it's going to be a liquid, not in rows like a solid. So there's our liquid. How do I know that it's squash and not a pure substance though? Because if it was just water, I would just be leaving them all the same colour, but we know it's squash. So there are two types of particles. There's sugar particles and there are water particles. So I need to colour some of my particles in, as many kind of as I want to. Okay, just to show, to represent that it is a mixture. So in squash, it is a liquid. There are two types of particles. What else? I can't remember what else we need to show. How many different parts? How they are arranged. They are arranged as a liquid, aren't they? Okay, and here's how they are arranged. They are as a liquid, they're arranged randomly, they are touching, and they can slide past each other so they can flow like a liquid does. Okay, so that's how we would show that in a diagram. Okay, what is a mixture? So this is where you're going to do some of your own particle diagrams. So, what is a mixture? Draw a diagram to represent a pure solid. Draw a diagram to represent a mixture of gases. Give an example, you don't need to draw anything for this one. Give an example of a solid mixture. Give an example of a liquid mixture. Give an example of a gaseous mixture. And when we say gaseous mixture, we mean two gases that are mixed. Okay, so pause now and have a go in your book at drawing for number 1, number 2, a little diagram. Number 3, 4, and 5, give an example. So write down an example of something that you might know. Okay, so pause now, have a go. Okay, answers. Your pure solids should look something like this. So they have got one type of particle arranged in rows. They are rigid, they are touching. And yeah, that's a pure solid. For number 2, our mixture of a gas. We know it's a mixture because there are two types of particles. The particles are arranged, they are not touching, and they are moving around. An example of a solid mixture is steel. Okay, we looked at that earlier. It's got carbon and it's got iron, so we know that steel is a mixture, a solid mixture. An example of a liquid mixture is water or squash, and we've looked at two of those examples. You might have had another one maybe. An example of a gaseous mixture is air, okay, and that's the one that we looked at earlier. So we've looked at all of those ones. Alloys. Right, an alloy is a mixture that includes a metal, okay, and we use alloys, we combine two metals sometimes because it makes things stronger. Okay, and let's have a look at that a little bit more. So you've got tin, copper, and bronze. Kind of nice bronze line there. So tin, copper, and bronze. Now, tin and copper are pure metals. They are made up of one type of particle. So tin would be shown like this. Okay, our tin particles are all the same. It's a solid, so they're in rows, and they are rigid. Copper is a pure metal. So have a think, what would it look like as a particle diagram? Let's show you. It would look like this, okay? Different colour to represent a different metal, but it's a solid, it's in rows, and they are rigid. Now bronze is an impure metal, and bronze is actually a combination of tin and copper. So have a think, what would this particle diagram look like? Let's show you. It would look like this, because it's a combination of tin and copper to make bronze. And there we go, we've got our mixture of tin particles and copper particles to make our bronze metal, our bronze alloy. Okay, and an alloy is a material which is made up of different metals. Okay. Another type, we've got carbon, iron, and steel. Now carbon, okay, is a solid again. It would be arranged in rows. It's rigid. They are all touching. Iron, again, is a solid metal. It's arranged in rows. They are rigid. Now steel is a combination of carbon and iron. It is a mixture. It is an alloy because it has two types of metal. And it would look like this because we have got our iron particles and our carbon particles combined together to make an alloy mixture, okay, because it's including metals as a mixture. So steel is stronger than just iron. And the same, let's go back with our bronze. Bronze is a stronger material than tin and copper. They are both quite soft. So pure metals are soft, alloys are strong. Okay? So there we go, another kind of diagram to show that. Pure metal and a pure metal makes an alloy. and we show that with our different particle drawings. So what do the particles in white gold look like? White gold contains gold particles and platinum particles. So this is where you're gonna have a go. What state of matter is white gold in? So think, is it a solid, a liquid, or a gas? How are the particles arranged? How many different types of particles are there? And we've given you kind of the particles that include here. Okay, so have a go. Draw out your particle diagram and answer those three questions. So what state of matter is white gold in? How many particles are there? How many different types of particle are there? Okay, pause now and resume when you are finished. Okay, now the answer should look something like this. So your diagram should look a bit like this one on the side here. Okay, and if you use different colours, that's fine. So we've got our gold particles and our platinum particles together because it's an alloy. Okay, and it's a solid because it's in rigid rows, don't move. So what state of matter is it in? It's in a solid. How many particles are there arranged? Well, there are two. How are the particles arranged? They're arranged in rows and they are solid. How many different types of particle are there? There are two. There are gold and there are platinum ones. Okay, what is an alloy? What's the difference between a pure metal and an alloy? Which metals make the alloy bronze? How is bronze different from pure metals? How do you know that bronze is a mixture? Pause and answer those questions now and resume when you're ready. Okay, answers. An alloy. So a pure metal contains only one type of particle, whereas an alloy is a mixture of different types of particle. So we know an alloy is a mixture of metals. So if you said something like that, that's correct. Remember to kind of check your answers and edit if you need to. The metals that make an alloy are bronze. Let me start again. The metals that make the alloy bronze are tin and copper. Number 3, bronze is stronger than pure metals, tin and copper, and that's why we make them into alloys, because it's stronger. Number 4, bronze is a mixture because it contains two different types of particle. That's what a mixture is. Oil and water. So this is where we will get on to do our experiment. Okay, so for this experiment, you will need some oil, some water, some soap, and a spoon. So pause now and go and get your bits and pieces, and we'll get on with it together. Okay, here we go. Okay, so to do this experiment, you're going to need some water, some oil, some washing up liquid, and a spoon. You also need an adult to help you out with this because it could get messy if you're not careful. So we're going to take our water and we're going to mix in our oil into the top. So we're just going to put it straight in and see what happens. Now straight away, if you look carefully, you can see there's air bubbles there, but oil and water don't mix straight away. But let's give it a bit of a stir, let's give it a chance. So let's mix it around. So our two liquids, see if we can get them to mix. Giving it a really good stir there. Do the same with yours if you're doing it as well. But you can kind of see, again, the oil comes to the top and the water's on the bottom again. It doesn't mix. There's lots of air bubbles now just because I've mixed it around. But there's no... They haven't blended together. They've not mixed together. So two liquids that don't mix, when substances don't mix with each other, we call it immiscible. Okay, it sounds like unmixable. So think of it that way. Immiscible liquids are unmixable liquids. Okay, immiscible. When things don't mix, immiscible. Okay, so we've got our oil and our water. Now, I did say that we needed some washing up liquid as well. So let's try a little bit of washing up liquid in this experiment too. Okay, I've got my massive pot of it. Put a little bit in. Don't need loads. Put that to the side. Get our trusty spoon again. This time, let's mix it round. And try and notice what happens. Try and see what happens. Observe. Now this time you can already see it's a little bit of a different colour. Now I would say they're definitely mixed this time. Just give it a bit of a chance to settle in case it hasn't. But that's definitely changed colour. It's now like a horrible yellowy greeny colour. Almost kind of snotty. So we've got now a mixable liquid. Okay, so it's mixed together. Now it was called immiscible. It's immiscible when they don't mix. So if they do mix, have a think about what it might be this time. It's called a miscible liquid. A mixable liquid. Think of it that way. Miscible. So now it's miscible. It was immiscible before. Now that's why we use washing up liquid to clean our pots and pans, because it turns oil and water into miscible liquids. So that's why we use soap on our hands, and why we use washing up liquid on our pots and pans, because it makes oil and water miscible, so we can then clean it off. Okay, so a little bit of kitchen science for you, so you can have a go at explaining that next time you're doing the washing up. Right, hope you enjoyed that. So our scientific vocabulary that we use there were miscible and immiscible. Miscible means mixable, immiscible means unmixable. Okay, they are our scientific words that we need to know. So miscible, immiscible, mixable and unmixable. So mixing oil and water, let's go through some questions based on what we've just done. What happens when you mix oil and water together? What's it called when two liquids do not mix? What happens when you add soap? What's it called when two liquids do mix? Okay, pause and answer the questions now. Right, answers. Oil and water do not mix. There is a layer of oil on top of the layer of water. So if you said they don't mix and the oil rises to the top, that's fine. Question 2. Two liquids that do not mix are called immiscible. When soap is added, the oil and water mix together. They are no longer in separate layers. Two liquids that can mix together are called miscible. Okay, and that's it for today's science. Hope you've enjoyed it, and we've got a bit of a better understanding of what a mixture is. Okay, see you next time. Bye, year 5.